You know, every single time you type a message, shoot off an email, or even just read a web page, there's this incredible, invisible translation happening in the background. It's called character encoding, and without it, honestly, our entire digital world would just be complete gibberish. Today, we're going to pull back the curtain on this universal language that your computer is speaking all the time. Oh yeah, you've definitely seen this little guy before, right? That little question mark stuck inside of Diamond. It pops up out of nowhere when you're browsing a website or reading an email, and it's just so frustrating. But what is it actually trying to tell you? Well, it's pretty simple, really. It means your computer is completely lost in translation. The device that sent the text and the device you're reading it on, they're speaking two totally different dialects of that secret language. It's a fundamental breakdown in communication. To really get why this happens, you have to understand a really basic truth. Computers, well, they can't read, not like we do. They have no idea what letters or symbols or even emojis are. They only get one thing: numbers. And not just any numbers, but really, really long strings of ones and zeros. So how in the world does a word like hello turn into that mess of numbers? Well, it's a process called encoding. And honestly, the best way to think about it is like Morse code. In Morse code, you translate letters into simple patterns of dots and dashes, right? Computers are doing the exact same thing, just with ones and zeros, which we call bits. So this whole thing is basically a five-step dance. First, a human types a message. Second, the computer encodes it into bits. Third, it stores or sends that data. Fourth, the computer on the other end decodes those bits back into characters. And finally, step 5, another human can read the message. When it works, it's totally seamless. But for a long, long time, step 2 was absolute chaos. The first big attempt to try and standardize this whole encoding mess was a system called ASCII. It came about way back in the 1960s, and you can think of it as the very first digital alphabet for computers.
You know, this timeline right here, it pretty much lays out our whole story perfectly. Back in '63, ASCII shows up. It's simple, it works great for English. But then, as computers start going global in the '80s, boom. Total chaos. And that chaos is what sparks the idea for Unicode in '91, this dream of a universal dictionary. And finally, that leads to the invention of UTF-8 in '93, which was the super clever system that finally made it all work.
The idea behind ASCII was super simple. It took 127 characters, basically the English alphabet, numbers, and some common symbols, and it gave each one a unique number. The capital letter A, for instance, got the number 65. In binary, that's 01000001. It was elegant for sure, but it had a massive American-sized blind spot. And yeah, that blind spot, it didn't just create a small problem, it created a digital Tower of Babel. See, the A in ASCII actually stands for American, and the whole system was built with English and pretty much only English in mind. So, I mean, think about it. What happens if you're in France and you need to type a C? Or you're in Japan and you need to write the character for big? Die. ASCII had literally no room for them. It just didn't have enough numbers to go around for every character in every language. So the result was a complete free-for-all. Different countries and different regions just started inventing their own encoding systems, hundreds of them, all clashing with each other. And if you tried to open a file using the wrong system, you'd get this kind of garbled, nonsensical mess. This was the digital chaos of the 1980s. But, you know, out of all that chaos, a really, really brilliant and ambitious idea started to form. A plan to fix this problem once and for all. It was called Unicode. Okay, now this is super important to get. Unicode itself, it isn't an encoding method. Think of it more like a giant universal dictionary. Its goal was simple but massive. Assign one unique number, they call it a code point, to every single character used by humans. Didn't matter what language, what program, what computer, one character, one number. Forever. And when I say every character, I mean it. Today, the Unicode standard has over 137,000 characters. It covers all modern languages, ancient scripts like Egyptian hieroglyphs, all the math symbols you can imagine, and yep, every single emoji you've ever sent. But look, having this amazing dictionary is only half the puzzle, right? You still need a really efficient way to turn those 137,000 plus numbers into actual ones and zeros. And that's where UTF-8 comes in. It's the clever code that actually brought the whole Unicode dream to life.
The absolute genius of UTF-8, which, by the way, was co-invented by Ken Thompson, one of the minds behind the Go programming language, is its variable width design. Instead of forcing every character to take up the same amount of space, UTF-8 lets characters be 1, 2, 3, or even 4 bytes long. This makes it insanely efficient.
And check this out. This is the really clever part. For the first 127 characters, the exact same ones from old ASCII, UTF-8 uses just a single byte. It always starts with a 0 bit. What does that mean? It means any old file written in ASCII is already a perfectly valid UTF-8 file. How smart is that?
Okay, but what happens with a character like ah? Its Unicode number is just too big for 1 byte. No problem. UTF-8 just uses a 2-byte pattern. See those first few bits, the 110? That's basically a little signal to the computer that says, hey, listen up, this character is 2 bytes long. Then the rest of the bits hold the actual number for ah. And this system is so flexible it just keeps going, all the way up to 4 bytes for the really complex stuff, like our good old smiley face emoji. Those first bits, 11110, just tell the computer to read the next 4 bytes as a single character. It's this beautiful self-correcting system that's both powerful and really hard to break.
So because of this ridiculously clever design, UTF-8 didn't just solve some nerdy technical problem. It fundamentally reshaped our entire digital world and made the global internet that we know today possible.
Just how successful was it? Well, the numbers are just staggering. Today, over 94% of all websites on the internet use UTF-8. It is, without a doubt, the standard for global communication, just quietly humming along in the background of almost everything we do online. And it also leads to some really cool kind of secret stuff with emojis. For example, did you know that an emoji with a skin tone isn't actually 1 character? Nope, it's 2. It's the base emoji, like the Vulcan salute, plus a special skin tone modifier character that your computer mashes together. The same thing happens with country flags. They're just 2 special regional letter characters put right next to each other. You know, this quote just nails it. UTF-8 is absolutely one of those foundational technologies that's so successful, so ubiquitous, that it's become completely invisible. It's the true unsung hero that lets us all communicate seamlessly across languages, cultures, and borders. So the next time you see some text on a screen, just take a second to remember the incredible journey it took, from a simple American code through total chaos to a universal system that can represent pretty much all of human expression. It really makes you wonder, doesn't it? Now that we've encoded our languages, what's the next great universal system we're going to need to build?